Which is the tendency of an object to resist changes in velocity? Of course, the answer is inertia, because inertia is a property of matter directly related to its mass. The more mass an object has, the more inertia it has. And the real-life example is when the car stops suddenly, your body's inertia means it continues moving forward. And that's why it's extremely important to use your seatbelt. Which law is represented by the formula A equal F net over M? Of course, the answer is D, because acceleration of an object is directly proportional to the net force acting on it and inversely proportional to its mass. Which is the gravitational force experienced by an object? Of course, the answer is weight, because mass is a measure of the amount of matter in an object, and the weight is the force exerted on that mass by gravity. And for your information, the mass never changes, but weight can change depending on gravity. Near Earth's surface, which is the value of the gravitational field G towards Earth's center? The answer is C, because 9.8 Newton per kilogram is equal to meter per second squared. Which is the condition where there are no contact forces acting to support the object, and the object's apparent weight is zero? Of course, the answer is C, weightlessness. And this is what astronauts experience in the outer space. Which is the force exerted by a fluid on an object opposing motion through the fluid? The answer is C, the drag force, because drag force is the frictional force exerted by fluids like liquids or gases on an object moving through them. Which is the constant velocity that is reached when the drag force equals the force of gravity? Of course, it's called the terminal velocity, because terminal velocity is reached when the upward drag force becomes equal in magnitude to the downward weight force. And then the net force now is zero. And according to Newton's first law, the object stops accelerating and continues at a constant velocity. Which is the term for two forces that are in opposite directions, have equal magnitudes, and act on different objects? Of course, the answer is interaction pairs. Because according to Newton's third law, the force exerted by object A on object B is equal in magnitude and opposite in direction to the force exerted by object B on object A. And a real-life example is the space shuttle launch.